today's video, we're going to learn how to use dimensional analysis to solve unit conversion problems. It's a new skill I want you to have and leave here today with is to how to solve basic problems using dimensional analysis. So we've been converting between units such as feet and inches, days and weeks, etc. The key, though, is to come away from here using the new skill of dimensional analysis. A couple key terms we need to look at. Dimensional analysis is nothing more than a problem-solving technique. Okay? That's what it is at its heart. It's a problem-solving technique. It is essential for solving what we call stoichiometry problems. Those are some math problems which we're going to be seeing very soon here. So we'll be seeing stoichiometry problems in our class very soon. Really, the only way you're going to survive stoichiometry is with the skill of dimensional analysis. So that's why we're going to be learning it today. It's something we're going to use down the road. One of the keys that we need to have during it is the knowledge of what a conversion factor is. Conversion factors are nothing more than something like 1 foot is 12 inches, 3 feet equals 1 yard, when converting in from one system of units to another. In order to use dimensional analysis, I think there's 4 steps that are pretty essential for you to have. Step number 1 is to write the 2 givens out. And I call the 2 givens a beginning given and an ending given. And the beginning given is found over here. This is the beginning given. Okay? That begins the problem. The other given is the ending given. Sometimes people call this the want, like the given and the want. This is the unit I want to get to. And the whole problem is going to be converting from the given to the other given. Step number 2 is fill the whole entire middle of the problem. This is the middle of the problem. And I'm going to fill it up with conversion factors. Conversion factors such as 1 foot is 12 inches per 1 foot, etc. We're going to make sure along the way in step number 3 that our units cancel out. Units canceling out means whatever unit, say feet, is up on the top here, I need to see feet down below. And I need to cancel them out in this direction. Lastly, it's to solve the problem. Actually use the math to solve the problem. And generally, anything that is on the top, I multiply against. And anything that's on the bottom of the equation, I actually divide by. And we'll work some problems out, so it should be pretty crystal clear. But as long as you stick with the 4 steps, these should be pretty easy problems for you. Alright guys, here's the thing. I know you can convert 36 inches into yards. I know you can. But what I want you to do, though, is actually use dimensional analysis to make the conversion. Okay? Step number 1. Write the givens down. Well, the first given is 36 inches. And the second given is converting it into yards. And I generally just space the problems out, giving myself way too much space probably, but that's all right. Step number 2 is to put conversion factors in between there. Okay? Now I need to get out of inches and closer to yards. And I'm going to use the conversion factor 12 inches per 1 foot. And the question really comes down, where does the 12 inches go? Does 12 inches go on top and the 1 foot in the bottom, or is it reversed? Units always need to cancel out. So whatever unit I have right here, I need to cancel it out with a division problem. I need to divide by it. So I'm going to cancel out, and I'm going to put 12 inches in the bottom and 1 foot on top. When I do so, the unit, inches, is removed from the problem. The problem has now been converted. It is converted into feet. Now, I do need to go to the unit yards. So I need another conversion factor to take me to yards. I'll use dimensional analysis again. Once again, I need to get out of feet, so I need to divide by feet or convert out of feet. And I'm going to say there is 3 feet in 1 yard. And when I do so, I now have converted out of feet, and feet is canceled out. And the unit that is left is yards. Anytime the unit that is left up here matches the unit I need to convert to, I know the problem is solved. How do I solve this? Let's do the math here, okay? It's going to be 36 times 1 times 1. That's going to be 36. The unit is going to be yards because there's nothing left there. On the bottom, I'm dividing by 12 times 3. That's going to be divided by 36. And I don't have a unit on the bottom. Okay, I don't have a unit on the bottom. Ultimately, you can see the division problem works out, and I end up with 1 yard. Specifically, I'm going to use 1.0 yard. Okay? Review the steps again. First thing, givens. Givens labeled. They drive the problem. Next, convert out of inches. I need a conversion factor that has inches in it. 12 inches in the bottom so that I can divide and cancel the inches out. Now I have foot on top. I need a conversion factor to take me out of feet, close to yards. 3 feet per 1 yard. Feet have now canceled out. I'm left in yards, and that matches what my problem needs to be in. I stop, and I solve the math. Multiplying across the top, dividing by the bottom. In the next problem, I want to convert 12,000 inches to miles. Okay? Some of the conversion factors that you'll need to solve this, I guess, would be in 1 foot equals 12 inches, perhaps. 5,280 feet equals 1 mile. I mean, there's a lot of conversion factors. Those should be the ones we need to convert this one. So let's get going here, guys. If you want to take a shot at this, please press pause. Use dimensional analysis to solve this, not just your calculator, but please work it out on a piece of paper showing that you could actually have learned the skill of dimensional analysis. Step number 1, write the givens. 12,000 inches. And the other given is what I need to go into. I need to go into so many miles. Okay, we've got the givens down. Step number 2 is the bigger step. That is, find the conversion factors. Now, you need to convert out of inches. So I'm going to choose a conversion factor that has inches in it. And I'm going to choose this one right here. And I'm going to put the 12 inches on the bottom because I need to divide by it in order to cancel out inches. So I'll put 1 foot on the top. Inches are canceled out. Great. I'm in feet now. And unfortunately, feet does not match up with this unit here of miles, so I need to do another conversion to convert out of feet. In order to convert out of feet, I need to put feet on the bottom. I'm going to put 5,280 feet per 1 mile. Okay, feet have been canceled out now. I'm left with the unit miles. Here's mile, and I also see it in the ending too. So I know the problem stops when they match. Now I have to go ahead and solve the problem here, okay? So it's going to be 12,000 times 1 times 1, which gives me 12,000, and that's going to be miles. On the bottom of the equation, I have 12 times 5,280, which gives me 63,360. So now I'm left with doing 12,000 divided by 63,360 to determine how many miles I have. And what I end up with is 0.189 miles. So 12,000 inches sounds pretty far, but in reality, it's not even a fifth of a mile. Okay? Once again, steps, givens. Step 1. Step 1, write the givens down, the units. Step 2, conversion factors. Step number 3, to make sure the units cancel out. Well, that one wouldn't cancel out, but even still. Step number 4, do the math. Okay? Excellent. Okay, if we get 8 hours of sleep a night, how many seconds of sleep is that? We're going to use it. Dimensional analysis to solve this problem. Dimensional analysis, as you see down here, is the method we're going to solve it. Having the right answer is okay. I really want to know, did you learn the process? Okay, so we get 8 hours of sleep. There's a given. Right there, 8 hours. And I want to go into the unit, how many seconds? So how many? Those are my 2 givens. That's my first step. The second step is to load up the middle with conversion factors, and I need to convert myself out of hours closer to seconds. Now, I don't know the conversion factors for hours and seconds off the top of my head, and so I'm going to do, in 1 hour, there is 60 minutes. That's really cool because now hours are gone and I'm left with minutes. Now, minutes do not match up with seconds. So anytime that doesn't happen, I have to make a new conversion factor. The conversion factor I'll do is in 1 minute, there is 60 seconds. Now, as you see, the unit here, seconds, cancel as the same as seconds over here. Anytime they match, the top here, top ending over there, I have to stop my problem. Minutes did cancel out, so I'm out of minutes for sure. Okay, let's solve the math on this. It's going to be 8 times 60 times 60. And on the bottom, it's going to be divided by 1 times 1. Okay, so let's do 8 times 60 times 60. And the answer we end up with is 28,800 seconds. Okay? Does everything line up? Okay, we started off with 8 hours. We converted out of hours into minutes. Minutes then cancels out and I convert into seconds, doing 8 times 60 times 60 to give me 28,800 seconds. Okay, a good night of sleep equals 28,800 seconds. All right, dudes. Okay, guys, how many work days would it take to you to earn $1,000 working 7 hours per workday at $8 per hour? Okay, once again, it's a kind of a good way to do it. I used to, earn about $8 an hour, and I'd always want to know how long it would take me to make $1,000, and actually dimensional analysis would be used to solve it. Okay, the given in this case is the unit money. Okay, dollars. You want to make $1,000. That's like the one given. Okay, here it is, $1,000. What else do I need to know? Well, my last given is going to be how many work days. Okay, so I'm looking for work days. How many work days? And I'm going to abbreviate that just for simplicity here, WD, work days. Okay, cool. Now, we got the conversion, we got the given done. That's step one. Step two is the conversion factors. Okay, I got two conversion factors in the problem. I have 7 hours per work day, okay? And I also have $8 per hour. Now, right now, I need to use one of those to convert out of dollars. In order to convert out of dollars, I need $1 in the conversion factor, and I have it right here. I'll put the dollar on the bottom, so it cancels out. $8 per 1 hour. Awesome. Dollar signs are gone. I've now converted the problem into hours. But I need to convert it into work days to stop the problem. Let's go a little further here. In the problem, I say there is 7 hours per work day. 7 hours per 1 work day. You'll notice now that the hours have been canceled out, and the unit work day matches the unit over here, work day. Problem will stop. Now it's time for me to solve it. I'm going to multiply across the top. 1,000 times 1 times 1 gives me, 1,000. On the bottom, 8 times 7 is going to give me 56. And you'll have to excuse me for writing this dollar sign. That's not what I meant to write. I meant to write work days. So 1,000 divided by 56. Let's have it, guys. And I'm going to need to work for 17.9 work days in order to earn $1,000 at $8 an hour and 7 hours per workday. Once again, I started the problem off with step 1 with the givens. Step number 2, I use conversion factors to convert the problem along the way. Step number 3, I canceled out my units along the way, dollar sign, dollars, hours, hours, left with workday. Step number, that was 2, and then 3 was to cancel it out. And step number 4 was to do the math in the problem, multiplying across the top, dividing across the bottom, 1,000 divided by 56 to give me 17.9 workdays. All right, guys, that concludes our little lesson on the introduction to dimensional analysis. We'll be picking up the next lesson with harder problems and just challenging a little more and eventually becoming pretty good with this so we can apply it to stoichiometry and chemical reactions. All right, guys, hope it was helpful. Have a good day.